As the closest star to Earth in the universe, the Sun hides countless secrets that completely overturn our understanding. Today, let's unlock together the hardcore truths behind this C-position boss of the solar system. First, let's go straight to the core question. What exactly is the Sun made of? I'm sure many people would blurt out, "Isn't it just a giant fireball?" But from an astronomical professional perspective, the Sun is a yellow dwarf star, a type of star. It is neither solid nor liquid, nor is it the kind of burning gas ball we imagine in everyday life. Instead, it exists in an extremely special state of matter called plasma. So what exactly is plasma? You can think of it this way. Heat a block of ice and it turns into water. Heat it again and it becomes water vapor. If you keep heating that vapor to tens or even hundreds of thousands of degrees Celsius, the gas molecules will be smashed apart. Electrons break free from the nuclei. What you get is a mix of positively charged nuclei and negatively charged electrons. That state is plasma. It's also known as the fourth state of matter. And the Sun is a gigantic plasma sphere, with a diameter of about 1.392 million kilometers, large enough to fit 1.3 million Earths inside. What's even more fascinating is that this plasma sphere is spinning like crazy, but its rotation is very different from Earth's. Earth is a solid planet, so it rotates uniformly. The Sun, however, is plasma. Its equator spins faster, while its poles rotate more slowly. The Sun's equatorial region takes about 25 days to complete one rotation, while the polar regions take around 35 days. This differential rotation is what gives rise to the Sun's spectacular sunspots, solar flares, and the corona. So why did the Sun end up forming as a plasma star in the first place? To understand that, we have to go back 4.6 billion years to a vast cosmic nebula. In the immense Milky Way, there was a huge cloud made of gas and dust, mainly hydrogen and helium. Later, a nearby supernova exploded. The shockwave, like an invisible giant hand, compressed this nebula. Under gravity, the material inside began to collapse toward the center. More and more matter gathered, denser and denser. Pressure and temperature at the core skyrocketed. When the central temperature reached about 10 million degrees Celsius, and the pressure became strong enough to squeeze hydrogen atoms together, nuclear fusion ignited. The enormous energy released by fusion created an outward radiation pressure. That pressure perfectly balanced gravity, pulling inward. At that moment, a stable star was born, and the Sun, in its plasma form, began its journey of shining and heating. That would last tens of billions of years. Simply put, the Sun holds its place as a star thanks to the precise balance between gravity and radiation pressure. If gravity were too strong, the Sun would collapse under its own weight. If radiation pressure were too strong, the Sun would explode apart. At this point, you're probably wondering why the Sun shines at all. The answer may completely shatter your intuition. The Sun doesn't shine because of burning like we see on Earth. Instead, it shines because of nuclear fusion of hydrogen atoms. The Sun's core reaches temperatures of about 15 million degrees Celsius, with pressures 250 billion times greater than Earth's atmospheric pressure. Under these extreme conditions, 4 hydrogen nuclei overcome their repulsion and fuse into a single helium nucleus. During this process, about 0.7% of the mass seemingly disappears. But that mass doesn't actually vanish. According to Einstein's mass-energy equation, E equals mc squared, it is converted into enormous amounts of energy. That energy is released in the form of photons and neutrinos, becoming the source of the Sun's light and heat. Every second, the Sun converts about 4 million tons of mass into energy. But with a total mass of roughly 200 billion trillion tons, this loss is barely noticeable. It is this continuous nuclear fusion that makes the Sun the energy mother of the solar system, nurturing all life on Earth. Here's a fascinating fun fact. The photons inside the Sun take hundreds of thousands of years to travel from the core to the surface. Many people think, since light travels at 300,000 kilometers per second, and the Sun's radius is only about 700,000 kilometers, shouldn't that journey be almost instantaneous? If you think that way, you're seriously underestimating how crowded the Sun is inside. The Sun's interior is jam-packed with plasma particles, A photon leaving the core is like someone entering a maze packed with people. Every tiny step, it collides with nuclei and electrons, gets scattered, absorbed, and re-emitted. It follows an incredibly twisted, random walk. Scientists have calculated that a photon experiences trillions of collisions on average, taking anywhere from 100,000 to 170,000 years to reach the surface. But once it escapes the sun and enters the vacuum of space with nothing in the way, it takes just 8 minutes and 20 seconds to reach Earth. In other words, the warm sunlight you feel today was actually born hundreds of thousands of years ago, deep inside the sun. When that light was struggling through the sun's interior, Earth was still in prehistoric times. Mammoths may have been roaming the plains, and human ancestors were still struggling just to survive. Even more astonishing is the fact that the sun actually has an atmosphere, and it's hotter than the surface. In December 2024, humanity, through the Parker Solar Probe, for the first time truly observed the sun's atmosphere. The Parker Solar Probe is the fastest spacecraft ever built by humans, reaching speeds of up to 690,000 kilometers per hour. At that speed, flying from New York to Los Angeles would take less than 2 seconds. What we see with the naked eye is the sun's photosphere, with a temperature of about 5,500 degrees Celsius. But at a distance of just 6.9 million kilometers from the sun, the Parker probe officially entered the corona above the photosphere. Its images revealed something astonishing. The sun doesn't actually have a true surface. This is the real boundary of the sun. Here, gas is no longer confined. Temperatures soar to 1 to 2 million degrees Celsius. The sun is constantly pouring energy into the universe. What the Parker probe captured wasn't visible light. Data showed that. The plasma in the corona doesn't flow smoothly at all. Instead, it's filled with violent turbulence, with backflows like wind being torn apart repeatedly and then pulled back by magnetic fields. Scientists also confirmed for the first time that the solar wind isn't simply blown outward, but is driven by continuous pushing and pulling from magnetic forces. As for why the outer atmosphere is hotter than the inner layers, that remains one of astronomy's great unsolved mysteries. Scientists call it the coronal heating problem. Another jaw-dropping phenomenon is jokingly described by scientists as the sun sneezing, and its power rivals billions of hydrogen bombs. On the sun's surface, solar flares and coronal mass ejections erupt frequently, like massive solar sneezes. These eruptions release enormous amounts of high-energy particles and radiation. If they happen to be aimed at Earth, they can disrupt satellite communications, damage power grids, and even cause auroras to appear at low latitudes. In 2012, the sun unleashed a superflare. Luckily, it missed Earth. Otherwise, human electronic systems could have faced widespread collapse, with potentially devastating consequences for life. Through precise simulations, scientists estimate that the sun has about 5 billion years of life left. Right now, the sun is in its middle age, with stable and relatively gentle fusion. In about 5 billion years, the hydrogen fuel in its core will run out. The core will collapse, and the outer layers will expand, turning the sun into a massive red giant. At that time, it will swallow Mercury and Venus, and may even engulf Earth. But there's no need to panic. 5 billion years is more than enough time for human civilization to evolve countless possibilities. After seeing all this, do you now have a brand new understanding of the familiar yet alien star above your head? The sun is not just a simple fireball. It is a plasma star that has followed the laws of the universe and kept running for 4.6 billion years. Its photons carry stories from hundreds of thousands of years ago, traveling across space to reach Earth, warming you and me. The mysteries of the universe are often hidden within the things we take for granted. A single sun is enough to make us marvel at the wonder and vastness of the cosmos. And in the Milky Way alone, there are hundreds of billions of stars like the sun. Each one holds secrets of its own. So next time you look up at the sun, remember that what you're seeing is not just light and heat, but a cosmic journey that began hundreds of thousands of years ago.